For this problem, we were asked to find the largest possible volume with 1,300 centimeters squared of material for a box that has no lid. Now our base will be x times x, which is equal to x squared for volume. And then the area of each side will be xh, and we have 4 sides, which means that our area will be equal to x squared plus 4xh, and we can set that equal to the amount of material we have. So this will be our constraint equation. And now we'll solve the constraint for h. And once we isolate h, we get 1,300 minus x squared all over 4x. Now moving forward, we will be using the volume of a box, which is v equals x squared times h, and we can substitute the h we just got into the equation, which leaves us with v equals x squared times 1,300 minus x squared all over 4x. Now, once we solve this, we will be left with and this is our volume function in terms of x. Now, to maximize the volume, we have to find the derivative and then set it equal to 0. So, doing so, we will be left with and then the derivative of this is now once we set this equal to 0 and solve for x, we will get something like this. And this leads us to solve x for about 20.8. Now that we have x, we can take x and input it into our height equation and find height. Doing so, it'll look like this. And now that we have x and height, we can find the volume. So our maximum volume will be equal to 4,510 centimeters squared. And that is your final answer.